Hello everyone, welcome for our next session. So I hope we are ready for 150 must do questions part 15. Okay, so we'll be going through again a mixed bag of problems, right? And with the crunch time that uh, you know we are in the crunch time, right? This is 1.5 months remaining. So therefore, ready, right? Let's buckle up and practice. Uh, all the different kind of expected questions, also some new concepts, right? Let's dive in. Here we go. Okay, so just to remind you that CDC 4 is something that you should be looking up. It is you can register for it up till 12th of November, and it is just going to give you the real feeling of the CAT exam, right? So your last CAT before the CAT, right? So that you don't feel something completely new on the exam day, right? You experience deja vu on CAT day, right? You feel that you've done it before, right? So therefore, something that you can look up to and take it so that you get the real feeling of the examination. Okay, so let's start with the session. Okay, so something on SICI, simple and compound interest. Ajay deposited a certain sum in a fixed deposit with interest being compounded annually. Right, so it's compounding. The interest earned for the first year was 9,000. The interest earned for the second and third year, they differ by 1750. You have to find the initial sum. Okay, so looks like we have to create the equations for this and solve that, right? So I think both the principal as well as the rate of interest, they are unknown. So we should create equations. What I'll do is I'll always keep on referring to the rate of interest in the fraction form, right? So I'll write small r to denote the fraction of the rate of interest. Okay. So can I say that basically this 9,000 is nothing but your r percent of the p principal amount, right? Simply because in the first year the interest is simply on the principal. So r percent of p, this is r percent of p, or simply p into r is 9,000. R percent of the first year's amount, which is p into 1 plus r by 100, or p into 1 plus r. So this will come to be p, right, into r into 1 plus r, right? Anand, we'll talk at the end of the session, right? Stay with, talk about this, right? So therefore, this is given to be, this is, I mean, we don't know this, right? We know the difference of the second and third year. So I will just write the expression for this. What will be the third year interest in a similar manner? R percent of second year's amount, right? So p into 1 plus r whole square, right? So this will be small r into this expression. So it will become p r into 1 plus r whole square, right? So these two, the difference is given. So I obviously the third year's interest is more. So third year interest minus second year interest. Third year interest minus second year interest. So the difference is given. So when we take the difference, PR 1 plus R whole square minus PR 1 plus R. So this PR 1 plus R is common in both. And in bracket, it will be 1 plus R from the first term minus 1. So this will be simply what? PR square, because this will also become R. 1 and 1 cancels. So PR square into 1 plus R. That is equal to my 1750. Okay, so we had to work through this very carefully, right? Perfect. Now we can solve these two equations. Obviously, dividing would help because the variable p, the principal, would get cancelled away, right? So when we divide, let me divide second with first. So PR will go away and I'll be left with second divided by 1, right? So I'll be left with R into 1 plus R, isn't it? And that is going to by 9,000. 10 cancels. 25 is common from here, cancels 7, 25 into 7. And here 25 into 375 and then 15, 156, 37 by 36. So R into 1 plus R is 7 by 36. Now 7 by 36 can be broken down as 1 by 6 into 7 by 6. So now it is in this form. So therefore we can clearly understand that R is coming to be 1 by 6. And hence we can put it back over here and we can get that P, the principal, right, is 9,000 upon 1 by R. So 9,000 upon 1 by 6, which is 54,000, right? So just a usual problem, had to carefully create the equations and uh, work it out, right? No magic, right? Some questions are have to be done mathematically, right? So I'm bringing all the flavors, right? Sometimes questions can be done in mind also, right? Sometimes we have to do the maths because you cannot work it out by some magical way, right? You have to work through the equations. Okay, perfect. Now time and work, next one. Let's see. A and B are assigned a project. When A works 10 hours, B works 8 hours, B contributes one third to the day's work. Immediately, what comes to my mind looking at this is I want to establish the relation between the work rates of the two persons and all, right? So let me denote the work rate as variable as, let's say, small a and b for the two persons respectively. So B contributes one third. What does A contribute? The remaining two third. So if A and B, they're contributing two third and one third of the work done by them is in the ratio of 2:1. And this ratio is the ratio between the work done by them in 10 hours and 8 hours respectively. So in 10 hours, work done by A will be what? 10 times his unit work done in 1 hour. Let's say 10 into A, right, is what he can do in 10 hours. And for B, it will be 8B. So basically, you can establish the relation between this A is to B, the ratio of the work rates. So I'm getting that 10A by 8B is 2 by 1, which means that I'm getting A by B as 8 by 5. I'm getting the relationship between their work rate of work as 8 is to 5, right? Perfect. Therefore, here comes my golden step. Assign the work rate. Let A be 8, B be 5 itself, because this is right. Either assign the work or assign the work rate. That is, that is how the problem starts, right? So we have assigned the work rate as 8 and 5 based on the ratio. We could have done 80 and 50. We could have done 16 and 10. I'm doing 8 and 5, simplest numbers, right? Now further, if A alone could complete the project in 30 days, working 6 hours, then in how many days they can together finish, and A and B working this hours respectively. So now comes the next step of defining the work. First, I have assigned the work rates. Now I will define the total quantity of work, right? So for A, it's 30 into 6, 180 hours work. So 180 A is the total work, right? That is the total work to be done. And A is 8. So this is 180 into 8 units. When they work in this manner, A working 7.5, B working 6 hours per day. So what is the rate achieved by them together? We can add the total rate and hence we can answer the question for the total time. So 7.5 hours for A, he can work 8 into 7.5 units of work. And B can work 6 hours, so 6 into 5 units of work. 8 into 7.5 will be 60. 60 plus 6 into 5, 30. 60 plus 30, 90. So the work rate is 90. This is the work done per day. We have calculated the daily work rate, right? And this is the total units of work that is there to be done. So what will be the time that will be taken? Total work upon total rate. So 180 into 8 over 90, which is coming to be 90 cancels, 2 into 8, 16. In 16 days, the work can be finished, right? So I think we have done this kind of question many times. So I have given you one more time a similar question, right? Where we first establish the work relationship between the work rate, then we assign the work rate, then we define the work, then we finish the problem, right? Pretty usual by now. Okay, let's see the next one. Here we go. Time and distance. Okay, let's see. Two buses X and Y. Two buses X and Y start together from cities A and B to reach city B and A on the road connecting them. Okay, so we have heard this story many times. Let's see something new. Bus X crosses bus Y after having covered 60% of the journey. After crossing bus X reduces its speed by 50%, bus Y increases its speed by 50%. Which bus takes more time to reach its destination and how much percentage more than the other? Distance is not given, speed is not given. Everything is in percentages based information is there, right? So therefore we can assign any suitable values. First information comes in front of us is the 60%, that bus X crosses bus Y after having covered 60%. What does that mean? It means that bus X has covered 60%, bus Y has covered 40%. So 60 is to 40, their speeds are in the ratio of 3 is to 2 because they started together. Clearly written over here, they start together. So whenever two objects start together, they are going to run for the same amount of time. So the ratio of their speeds is going to be the same as the ratio of the distance covered by them, right? So therefore, what we can do, assign the values. Let's say the total distance is 100 kilometers. Let's say this is 60 kilometers covered by bus X starting from here. And let's say this is the remaining 40 kilometers covered by bus Y starting from here. Also, let's assign the speeds, right? It does not matter that what we do. No, Anansina, this time not it is not D. It's not D this time. Um, Look at this. So, so I was saying let's assign the speed. Okay. Mm, so speed has to be also in the ratio of 3 to 2, isn't it? Let's say this was only 60 kmph. Let's take it 60 kmph only. Okay. The bus X coming from here has the speed of 60. And let's say the bus Y coming from here has the speed of 40 kmph. Fine. So both of them take 1 hour to meet, right? So let's track the total time taken by bus X and bus Y. They both take 1 hour to first meet, and then we'll add the time that they take to reach the destination finally. Because remember, we have to find the total time taken by them to reach the destination, right? So bus X reduces the speed by 50. So bus X has now the speed of 30 only over here on its second half of the journey, and bus Y increases the speed by 50%. So 40% will become 60. So this bus will now be moving at the speed of 60. Bus Y. This is the journey of bus X. This is the journey of bus Y. So what time will bus X take to move the remaining distance? 40 kilometers to be covered at the speed of 30. So time is distance by speed, 40 kilometers upon 30 kilometers per hour. So 1 plus 4 by 3 of an hour, or is total of 7 by 3 hours, right? Let it remain in fraction. Bus Y on this side, it will now be moving at speed of 60 to cover 60 kilometers. It will take 1 hour, right? 60 kilometers, 60 kmph, 1 hour. So 1 plus 1, 2 hours. Obviously, bus X has taken more time. 7 by 3 means 2.33, right? So therefore, what is the percentage? How much percentage more time is taken by bus X, right? Bus X has taken more time. How much percentage more? So 7 by 3 is 2 plus 1 by 3. So the percentage increase in time is 1 by 3 hour more with respect to this 2 hour. So therefore this is 1/6 in percentage in fraction form, or 16.66%. So bus X takes more time. How much more time? 16.66 percentage more time. Right. I guess, Anand, I think you were calculating for only the time taken to reach the other destination after crossing, but that's not what the question is asking. Which bus takes more time to reach its destination? Destination is something that started when they started from cities A and B, not when they met. That was in the middle of their journey. Their journey started when they initiated from city A and B, right? So that is the trap option, option D, right? To miss the point of the question, isn't it? Yeah. Okay, let's see. Next one, geometry. Nice looking question. Okay, so let me give you some time on this. Okay, let me give you some time on this one to try. Okay, let's do this. Right, so figure is given in front of us. We have a triangle. It's a right angle triangle. AB is given as 30, BC is 40. We define the radius of this inscribed semicircle, which has its diameter on BC and it is touching AC. This radial line that you can already see over here, which has been drawn, creates a smaller triangle. And look at the larger triangle, right? So triangle geometry is the key over here. The point is, let's say this point is P over here. Look at this triangle OPC. Obviously, this is 90-degree because the radial line is tangential, to the tangent. It is always at 90-degree to the tangent, right? And look at this angle theta. So what I'm trying to say is that CPO and CBA both are similar right angle triangles. So you can apply similarity over here because they have two angles same. So they are similar. Theta 90, theta 90. So work it out, right? Let's say the radius is R. So OB being R, the whole of OC, since BC is 40, so OC will be 40 minus R. This is already 30, right? So what we can say, opposite to theta we have OP. I'm writing the condition of similarity that the ratio of corresponding sides is same. Opposite to theta we have OP, which is R. Opposite to theta we have AB, which is 30. So OP by AB, OP is R, AB is 30, equals, okay, so opposite to 90 in triangle OPC we have 40 minus R, and opposite to 90 in triangle ABC we have 50. AC is 50, it's 30, 40, 50 triangle. This is the equation, should give you the answer, right? Zero cancels, cross multiply, simple question. 5R equals 14 to 3, 120 minus 3R. 8R is 120, R is 15, right? Done. Yes, Anand, there are multiple ways you can also do that. Extending the triangle and using in radius, right? Yeah, we can do that also. Multiple ways. I just solved this directly, applied similarity in the given figure. Perfect. Good to see that you are like you're showing your different style. Yes. What Anand is saying, just double this figure and complete another triangle and complete the whole circle. Means with this triangle, just draw another congruent triangle below it and then form the whole in circle or for this whole triangle, and then you know all the dimensions of this triangle and then apply the in radius formula, right? That can also be done. Okay, good. Let's see next one. Here we go. Okay, so yes, you should be able to get this one as well. I'm giving you a minute to try. Okay, so let's see. Yeah, so it's a word problem, right? In which quadratic will be used. So 2 years, because this is the square relation over here. So 2 years ago, Mr. Rao's age was equal to the square of his grandson's age. So if the grandson was, let's say, X years, then Mr. Rao was X square years old. This was 2 years ago. 4 years hence is 6 years from this time, right? From 2 years ago to 4 years hence. 2 years in the past to 4 years in the future is a gap of 6 years, right? So we are moving further 6 years. So each of them will grow older by 6 years. So grandson will have become x plus 6. Mr. Rao would have become x squared plus 6. And then he is given to be equal to 5 times of his age, right? So x squared plus 6 is therefore 5 times of x plus 6 is the equation. We have to just solve it out. X squared, 5x comes over here, minus 5x. 30 comes here, 6 minus 30 minus 24 is 0. 24 is 8 into 3, and so this is very easy factorization. X minus 8, x plus 3. So x is coming to be therefore 8. X is 8. Now, answer is not the value of 8. Question is asking how old was Mr. Rao when his grandson was born. When grandson was 8 years old, Mr. Rao was 64 years old. So grandson was born 8 years ago when he was 0 years old. At that point of time, Mr. Rao was 64 minus 8, which is 56 years old, right? Isn't it? So, but just a usual question, right? Have to be just very at the last, just be very clear about what is being asked, right? Just a very usual question, I guess, right? Word problem in which quadratic had to be created and solved for. All right. So this was an easy one. But what about this one? Right. So I'm bringing you all the flavors. The last one was pretty straightforward. Now comes a meaty question. Functions, CDs, right? Okay, let's jump in. A non-zero function, FR to R, means it has the domain of all real numbers. is known to satisfy the following relations for all real numbers x and y. And two relations are there: f of x plus y is f of x plus f of y, and then f of x square is f of x whole square. What is the value of the infinite sum? So the question is in two stages. First, you have to solve and identify the function, and then you have to do this infinite sum. Hence, it is a question of both functions and series. Okay, let's see. This is a very standard functional equation. If you have done functional equations, then you must have been you must have looked at this kind of relationship, and you must be knowing that the function which satisfies this kind of relation is always of the form fx equals kx, where k is a parametric constant. Means for any constant k, fx equals kx always satisfies this relation, that f of x plus y equals f of x plus f of y. Because k into x plus y will be equal to k into x plus k into y. As simple as that. But in this, k is unknown. Means for any k, this is always satisfied. But we have also this. So with fx being kx from the first relation, we can now put this function in the second relation to get the value of k. So f of x square will be kx whole square or k square x square equals, sorry, f of x square, right? What will be f of x square? Kx square, right? F of x square, so will be kx square, because k will remain k and x square. And what will be f of x whole square? F of x will be kx whole square is k square x square. So we are getting the equation that kx square equals k square x square. X square cancels. So we are getting k square minus k is 0, or k into k minus 1 is 0. K is either 0 or 1, but k can't be 0 because it's a non-zero function. If k becomes 0, then function also becomes 0. Function is non-zero. With k equal to 0, function will become fx equal to 0, which is not allowed as per the very first word of the problem. So fx is simply x. With k being 1, fx is simply x. So fx being x, each value of the function is nothing but the input itself. So now what about this infinite sum? Now let me clear this, because we have identified from this working that fx is x. Now we have to solve for this infinite sum. So this infinite sum, let's call it a. A becomes f of 2, which is 2, plus, so f of x is simply x. So just all the input values are the output itself. So 2 plus 4 by 5. So now the question becomes, find this infinite sum: 2 plus 4 by 5 plus 6 by 25 plus 8 by 125 and so on. Right. So the logic is powers of 2 in the numerator and uh, sorry, 2 4 6 8, not powers of 2, 2 4 6 8 even numbers in the numerator. So like next term will be 10 by 625 and powers of 5 in the denominator. Means the nth term is 2n upon 5 power n, right? So we have to find this infinite sum. All the options are also there in fraction form. We have to solve it now. We have done this kind of question also many times. I have told you, whenever you have this kind of equation, this kind of series in which you see something which is having an element of geometric progression, at the same time the coefficients are having a different pattern altogether in themselves, right? Multiply on both the sides with the common ratio and subtract, you'll get simplification, right? So multiply this with 1 by 5, multiply with the common ratio, which is 1 by 5. So a by 5 becomes 2, becomes 2 by 5. Write it below the next term so that the denominator matches and we can subtract easily. 4 by 5 becomes 4 by 25, 6 by 25 becomes 6 by 125, and so on, right? So now on subtracting, I guess we will get a very simplified expression which we can solve for. So a minus a by 5, which means 4/5 of a, is therefore 2 plus, now all the numerators will become 2 on subtracting. So 2 by 5, 2 by 25, 2 by 125, and so on till infinity, right? So this summation is infinite GP. That too is a separate term, not a part of this GP. GP starts from here, right? So 4/5 of A is coming to be 2 by 2 plus infinite sum of GP, first term upon 1 minus common ratio. So 2 by 5 upon 1 minus common ratio, 1 minus 1 by 5, 4 by 5. So 2 by 5 upon 4 by 5 becomes half. So this is 2 plus 1 by 2 or 5 by 2. Hence, 4/5 of A is 5 by 2. A is coming to be 5 by 2 into 5 by 4, which is 25 by 8, is the required sum of the series. Right? So a very properly designed question which tests your deep knowledge on functional equations as well as series. Right? So you should know these functional equations, right? And this series, we already know how to do it. Perfect. Yeah. Okay. Next one you will try. This one was a bit time consuming, I would say, but I think we have learned a lot of concepts. Okay. So PNC, this question you should try. Let's see. I would wait for your answers, right? Please try. Okay. So uh, while you're trying, let me start. So we need to have 3 digits in a 4-digit number. Means the number is having digits like A, B, C, and then another digit which will be one out of A, B, C again, right? So it could be A, B, C, C, it could be A, B, B, C, something, right? So the point is, we know that when we are forming a 4-digit number, dash, 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 zero can't come here at the thousands place. So in my selected pool of digits, if I have selected 0 or if I have not, creates a difference in terms of my arrangement. Very nicely done, Anand. Very brilliant answer. Thank you. I was not expecting a correct answer to come on this one. Very good. Right. Yeah. So I was saying that whether 0 is there or not creates a difference in terms of how I will arrange. So therefore, I have to form the cases based on whether 0 is there or not. So in case 1, I will say that ABC, all of them are non-zero digits, right? There'll be multiple cases in this problem because whether 0 is there or not creates a difference. Case 1, all the three ABC are non-zero. ABC are non-zero, right? So this is a question of permutation. In any question of permutation, we have to first select, then arrange. Permutation is always a two-step process. First decide to select what you have to arrange and then arrange it. So you have to select first of all ABC. 9C, 3 ways that you can select A, B, C. Then after selecting, you have to decide which amongst ABC will repeat twice. 3 ways for that. Whether your digits are AABC or ABBC or ABCC. That's what I'm talking of. Those 3 ways to decide which digit will repeat twice, right? 9C, 3 ways to decide to select ABC. Why? Because we are selecting non-zero digits. 3 ways to then decide which digit will repeat. So this is my selection is done. My selection of 4 digits is done, and then comes the arrangement part. Now we have number of the form AABC kind of number. 4 objects out of which 2 objects are repeating. 4 factorial by 2 factorial ways to arrange. This is my first part. Case 2, 0 is there. Now case 2 is not, again, it's not a single case. Because whether 0 comes once or twice, that's another story. So you have to form actually 2 more cases. A, B, C, AB, AB 0, 0. AB 0, 0. 0 comes and repeats twice. Possible. 0 can come in the last 3 places. The 2 zeros can come in the last 3 places. Possible. So again, first select, then arrange. 0 is already selected. Fixed above. A and B have to be selected. So 9C, 2 ways to select A and B. Right? Now A and B are only coming once. So only we'll select them. That's all. That selection is only 9C2. And then comes arrangement. Okay. After selecting, so this is my selection is done. Clear? Because 0 is already fixed. We have selected 2 zeros. A and B can be selected in these many ways. Now arrangement of AB 0, 0 cannot be done freely, right? First you have to decide where the zeros will come. In how many ways the zeros can come? These are the 3 places now. So either hundreds and tens, or hundreds and units, or tens and units. 3 ways to arrange the zeros. Zeros can be arranged in 3 ways, right? Amongst the last 3 places, they can occupy the 2 positions in 3 ways. Then once they are arranged anywhere, let's say at the units and tens place, then at the remaining 2 places, A and B can be arranged in 2 ways, 2 factorial ways. So this is my second case, right? Then comes my third case. When my number is of the form A, B, something repeats, either A or B, and then 0. These are my digits. Again, 9C, 2 ways to select A and B, and then into 2 to decide whether A or B will repeat. So this is my selection. Just like we did into 3 over here, likewise over here, 9C, 2 ways to select A and B, and then into 2 for deciding whether A will repeat or B will repeat, and then arranging them. So basically my digits are of the form A, B, 0 kind of thing. Again, first I have to take care of the fact that 0 cannot come at the thousands place. So 3 ways again to arrange the 0 at the remaining 3 places, right? Then let's say my digits are like A, B, 0 kind of thing. So 0 is already arranged. B can go in any of the remaining 3 places. So into 3 for arranging or placing B among the remaining 3 places. And then the A's are fixed to go in the remaining 2 places. Add this, you'll get the answer 3888. Just do this calculation, that is what you will get. Perfect. So I think little time consuming question, but this question tells us that sometimes we are forced to make cases, right? It's a one-liner, but time-consuming question, right? Can be done. Is this kind of question should be done in your like your second or third, you know, scrolling through the questions, maybe in the last 10 minutes, right? Not your first question to be done. Okay, there we go. Next one. Okay, so something interesting again. Let me give you some time to digest this question. Please look at this one. All right, let's see. The pocket money of three siblings, Arun, Varun, and Charu, is 3, 4, and 5,000 respectively. In the following month, the total pocket money of all the three increases by 20%, while no individual's pocket money decreases by more than 10%. What is the highest possible percentage increase in any sibling's pocket money? 3 and 4 is 7 and 5 is 12. 12,000 is their total pocket money that is increasing by 20%, right? 12,000 is the total pocket money, which increases by one fifth, 20%. One fifth of 12,000 is 2,400 bucks, right? So 2,400 is the total increase in the pocket money of all the three children, but we don't know respectively how much increase the three children receive, right? So we have to decide how much of an increase to allocate to each of the children such that one of the children has the highest possible percentage increase in its value. So the point is, this is a question of maxima minima, in which you have to decide which child we should decide to have the highest possible percentage growth in the pocket money. So which child you will decide? There's a very small, there's a very subtle logic over here. If you let's say give 1 rupee to Arun, 1 rupee to Varun, 1 rupee to Charu against their current pocket money amounts, or let's say 100 rupees, or let's say 1,000 rupees, whatever. Let's say give 1,000 to each. Who will receive the highest percentage increase in their amount? I've given the same amount to all three, 1,000, 1,000, 1,000. Who will actually end up having highest percentage increase? Although the increase is the same, but the percentage increase is not the same. Because for Arun, 1,000 is 33.33%. Whereas for Barun, it is only 25%, 1,000 by 4,000. Whereas for Charu, it is only 20%. So the higher the amount, the lower the percentage for the same value. So obviously, we should decide to give Arun the highest growth, because any rupee given to Arun always returns a higher percentage growth. The point is the denominator being the smallest, the percentage increase being the highest, right? So now we are having one more constraint, that no individual pocket money decreases by more than 10%. So we would want the other two children, Barun and Charu, to have the smallest possible pocket amounts. So this is the limiting factor. It cannot go down by more than 10%. So more than going down by 10% means the new pocket money has actually decreased by 10%. It has become 90% of the initial, right? So Arun will go from 3,000 to somewhere. Barun and Charu, we will decrease their pocket money, right? For Barun, it will be 4,000. It will go to 3,600 minus 400, right? Charu will go from 5,000 to 4,500. So we are decreasing their pocket money by 10%, the maximum possible limit that is given to us. So minus 500 for Charu. but we need to have a net of plus 2400. So we are down by 900 by now. So here we have to add 900 plus 2400 to have the overall plus 2400 effect. So 900 plus 2400 is 3300. So Arun's pocket money will increase by 3300 and become 6300, which is a 110% increase. 3300 is 110% of 3000, right? So a very subtle point over here, right? How this question makes use of the concept of percentage change, right? Okay, people. So another session, I guess, something we are taking away from this, right? So hope to see you in the next one. Let me remind you a few things. CAT 2025 Power 30. This is our latest offering. 15 sectional tests, 15 sessions, 15 CDC mocks, right? So something that you can look up to and make use of if this is in this crunch time to, you know, I guess this is the testing phase that we are now actually into, right? So um you know, Power 30 is from our side the most useful thing that students are making use of for their preparation. So look out for that, right? So with that, I think I'll sign off. uh, Anant, I'll address your point. Anant, again, this is everybody's asking this question. I am sitting at this mock score, what to do? Just chill, right? I would say just be calm, nothing else. You are doing fine. You are at 30 35, which means you are at 99 plus, 99.5 plus percentile, right? 10 net questions correct or 10 to 12 net questions correct is 99.5 plus percentile. So they are all, you're already there, right? You just need to just stay focused, just stay calm, nothing else. You don't need to do anything. You're doing fine. Just need to just be very self assured. That's all. Go in the exam hall as if you own, the exam. You know what it is. That's all, right? You will go places. All right. So thank you, people. I hope to see you again, and also make use of the Calendar mobile app, right? Thank you. Thank you so much. All the best. All the best.